Lesson 2.8, Proportions and Similar Figures. There is no vocabulary for this section, so you can automatically just write this down in your notes. You can use proportions to find missing side lengths in similar figures. Such figures can help you measure real-world distances indirectly. This symbol means is similar to. So we would read this following statement as, in the diagram, triangle ABC is similar to triangle DEF. Problem 1. In the diagram, triangle ABC is similar to triangle DEF. What is the side length DE? So we are trying to figure out this missing side length here. And the question is already telling you that the two triangles are similar. So to figure this out, we're going to need a plan. Okay? Write a proportion involving two pairs of corresponding sides. The length of side DE is the only unknown, so you can solve for it. So step 1 is to write a proportion. The first fraction that you see here are the two similar sides of the two triangles. So side length BC is similar to triangle EF. They are corresponding sides. Equals side length AB over side length DE. They are the other two corresponding sides. Step 2, you're going to substitute the lengths. So side length BC is 6, EF is 12, AB is 10, and DE again is the side length we're looking for, so we can give the variable x. Once you have the proportions set up, you can just use the cross products property to solve for x. 6 times x equals 12 times 10. Multiply. 6x equals 120. Divide each side and simplify, and you get x equals 20. Always go back and answer the question, because the question was asking you what is side length DE, so you can simply write out side length DE is 20. Problem 2. Applying similarity. The sun's rays strike the building and the girl at the same angle, forming two similar triangles shown. How tall is the building? So again, in step 1, we're going to want to write a proportion. Now, given that this is a word problem, we have to look at this a little more in depth. So you see here, the first fraction is talking about the shadows, equals the other fraction is talking about the heights. Okay? So when you're writing a proportion with a word problem, the two fractions should involve the same things. So in the first fraction you see shadow, in the second fraction you see height, and the numerator should be of the same content, girls, and the denominator should be of the same content, buildings. Step 2, you're going to substitute the values. So the girl's shadow is 3 feet. The building's shadow is 15 feet. The girl's height is 5 feet, and the building's height is x feet, the unknown. Use the cross products property. 3 times x equals 15 times 5. Multiply. 3x equals 75. Divide and simplify. X is equal to 25. Now again, being that this is a word problem, you always want to go back and answer the question with the specific unit. So the building is 25 feet tall. Let's do some sample problems together. So go to the back of your notes section and copy this problem down, and we'll do it together. So this says, use the diagram below. What is the side length of x? This is similar to problem number 1. So we have similar triangles. We have this side, this base is similar to this base. And this side is similar to this side. So the red lines are going to be our first fraction, and the green lines are going to be our second fraction. Now keep in mind, if I start with this triangle, that means these side lengths are going to be in the numerator, and the bigger triangle is going to be in the denominator. So let's see what I'm talking about. I said the red lines are going to be our first fraction. So 3 over 21 equals, and notice I said the small triangle needs to be in the numerator. 3 is in the numerator, so our other fraction is going to be green. I started with the small triangle, so again, x is the small triangle numerator over 14. Okay? Then we're going to use cross products. We have 3 times 14 equals 21 times x. 3 times 14 is 42. 21 times x is 21x. Divide both sides by 21. And you get x is equal to 2. All I wanted to know, the question was, what is the side length of x? There are no units. Remember, go back and answer the question. So since there's no units and all it's asked is what is the side length of x, you can leave your answer as x equals 2. Let's do one more. A man who is 6 feet tall is standing next to a flagpole. The shadow of the man is 3.5 feet, and the shadow of the flagpole is 17.5 feet. What is the height of the flagpole? So this is similar to problem number 2. Let's highlight what we know. So the man is 6 feet tall, and the shadow of the man is 3.5 feet. So those two go together. And then we also know that the shadow of the flagpole is 17.5 feet, and we want to know the height of the flagpole. So again, one fraction is going to represent height, and one fraction is going to represent the shadow. So we can write this out as, we could put man height over flagpole height, and I'm just going to abbreviate man with M and flagpole with F, equals man height. So we need to put man shadow over flagpole shadow. Okay? Men is in the numerator, flagpole is in the denominator. Now let's substitute our values. The man height is 6 feet over the flagpole height. Do we know what the flagpole height is? No, because that's the question. So we're going to label that with the variable x equals the man's shadow is 3.5 and the flagpole shadow is 17.5. Let's cross product. 6 times 17.5 equals x times 3.5. 6 times 17.5 is 105 equals 3.5x. And if we divide both sides by 3.5, we get 30 equals x. Now you might say, okay, we're done, but we're not. Go back and answer the question. What is the height of the flagpole? And we see that the units here is feet. So you can simply write down that the height of the flagpole is 30 feet. You can write equals 30 feet. Okay? Remember, word problems always go back and answer the question that's at hand. All right? Be prepared to discuss these problems in class and be prepared to do more problems like these. See you mañana.